Good morning, good afternoon, depending on where you are. I'm Guy Johnson from Bloomberg Television. I'm going to be your moderator over the next hour of the FIA Connect CTO Roundtable. The agenda is a fairly straightforward one: reaching net zero, setting the sustainability agenda. We've got a fantastic group of CTOs to talk about how we are going to make the transition, and the timing couldn't be better. The pressure is definitely on to decarbonize. As we speak, Frans Timmermans and Ursula von der Leyen are delivering a press conference in Brussels, laying out what will be probably the most ambitious, multilateral climate strategy shift ever attempted. A significant acceleration. The news over the last few minutes, I'll just check my Bloomberg, talking about the fact that the EU is going to seek to phase out free CO2 permits for airlines by 2027. That doesn't feel like it's a very long way away at the moment. So the challenge is definitely real, and the challenge is definitely present. Airlines, though, certainly are at the moment trying to step up to the plate. Half of all the world's major airlines, my understanding is, have now set a net zero target since 2019. The problem is, though, that they, at this stage, are really struggling for options. The only economic option they have in terms of meeting some of their targets are basically offsets. I don't think they're going to be very sustainable for very long. Consequently, if we're going to reach some of these targets, and I'm interested to see what Ursula von der Leyen has to say in terms of more detail, we're going to need other options. Sustainable aviation fuel clearly is going to be one of those, but is that still just a stopgap as we make the transition to more sustainable long-term technology? The government needs to provide incentives even for that to happen. And again, changing the policy around exactly what we favor. Is it sustainable aviation fuel? Is it sustainable diesel? I think is going to be absolutely crucial here. But hydrogen, battery hybrids, new propulsion technologies, new designs for airframes, improving ATC, everything needs to be on the table. And as I say, fortunately, we have a fantastic panel to be able to talk about that. Sabine Klokker is the Airbus CTO. Naveed Hussain joins us from Boeing. Chris Lawrence from GE. Paul Stein from Rolls-Royce. Eric Dabliez from Safran. And Mark Russell, all joining us. Mark joining us from Raytheon. So the format is going to be fairly straightforward. What we're going to do is we're going to give each of our panelists around 3 minutes to talk either about the kind of the sustainable aviation side, the propulsion side, or kind of third generation flight, new airframe designs, et cetera, et cetera. And after that, we'll basically piece it all together, try and get a sense of kind of where we're going and how quickly we can get there. If you want to join in the debates, the format certainly allows for that, and I'll try and introduce questions on the platform throughout the kind of the latter parts of the event. So let's get going. Let's get a sense of kind of where we are and the kind of trajectory that we are on. Sabine, let me hand things over to you first of all to give us your take on your sense of direction from the Airbus position.
Yeah, thank you, Guy, for the introduction. And as well, I really would start with welcoming all the audience around. So I'm really glad, first of all, to be with all my fellow CTO colleagues this afternoon. And it's so important that Airbus continues contributing to our industry's CTO collective. And here I'm really happy to build upon the foundation which was put in place by my colleague Grazia Vittadini, who I actually succeeded just at the beginning of July. So you have my personal commitment to continue elaborating our joint interests and even further to the best of my capacity. The aviation industry, and Airbus included, has committed to industry-wide decarbonization targets set out by ATTAC. And the fact is that these ambitious targets cannot be achieved using existing aircraft technologies today. So at Airbus, we believe that alternative propulsion systems and also alternative energy sources will push technologies in the right direction to help reduce emissions in aircraft of today and tomorrow. So this is why we've been evaluating various concepts and maturing a number of solutions. So electricity being part of it, hydrogen, but also for sure sustainable aviation fuels. So as you probably know, we have launched our program, which is called Zero E, which is a 3-concept aircraft for a short-range turbofan, a blended wing body, but also a turboprop design, which all rely on hydrogen as a primary power source, and which we push forward in order to really launch a zero-emission aircraft. It is also critical to us to push forward with the production and uptake of sustainable aviation fuels. And here, we at Airbus are jointly committed with ATAC, ICAO, the World Economic Forum, and civil aviation bodies to really make it happen and to make the large-scale use of SAF, of sustainable aviation fuel, a reality. All commercial aircrafts are already certified to fly with up to 50% blend of sustainable aviation fuel. And together with Rolls-Royce, and Paul Stein is here in the audience and in the panel as well, we recently demonstrated even that we can fly 100% SAF today, and that it's in our reach actually to get that certified as well. So I think a global transition to sustainable aviation fuel will require collective and urgent action. First, across the energy sector to really make SAF available, as well in the certification and with the regulatory bodies, with ICAO, ATAC, to make it flyable, but also with our political stakeholders, because we need incentivizing the uptake of sustainable aviation fuels. And here for sure we need then as well our customers and engine suppliers in order to make it happen. And nonetheless, academia and research institutions are key for us to really go forward. So decarbonizing the aviation is a significant goal for all of us around the table today, and we're all agreeing on that. We clearly have the right level of ambition. Now we need to accelerate and progress in the regulatory frameworks, in the public policy support, and as well in the technology pathways to secure the industrial ramp up and to ensure economic efficiency. So it's great to see that Farnborough reorients us towards this collective ambition. And I really look forward to the discussion this afternoon. Thank you.
Sabine, thank you very much indeed. Okay, let's carry on the conversation. I'm going to start with the OEMs. So Naveed, let me hand it over to you to pick up.
Thank you, Guy. It's a real pleasure to be here. Thank you for having me. It's great to be here with my industry colleagues as well. So over the past century, air travel has connected people really around the world. By 2050, we see a world where we carry 10 billion passengers a year, support 180 million jobs, and generate nearly $9 trillion in economic activity, all while minimizing the impact on our planet. It involves a portfolio of solutions and partnerships. And our portfolio at Boeing really to decarbonize this future includes 4 pillars. First, fleet renewal. New airplanes, new products provide significant efficiency gains. Each generation reduces fuel and emissions between 15 and 25%. So fully deploying these latest generations of airplanes is the most significant contribution of carbon emissions reduction available over the next decade. The second pillar is really around network operational efficiency. So the industry continues to collaborate on how to operate and fly more efficiently across the fleets. And this can collectively reduce emissions by nearly 12%. It involves procedures such as continuous descent approaches, GPS-based navigation, and this enables more direct routings. The third pillar is really around renewable energy transition. This is crucial for aviation to reduce carbon emissions. Sustainable aviation fuels offers the most immediate and largest potential to reduce carbon emissions over the next 20 to 30 years. That's why in January of this year, Boeing announced that our commercial airplanes will be capable and certified to fly on 100% sustainable aviation fuels by 2030. And Guy, this morning, Boeing announced that we will be partnering with Sky Energy Americas to focus on scaling the availability and the use of sustainable aviation fuels globally. We're going to be investing in their production project, and this takes the capable airlines, and it takes a capable airlines and an ample supply of SAF to decarbonize and drive this adoption across our industry. And we've really been aspiring to be a pioneer in making sustainable aviation fuels a reality, partnering globally with airlines, industry, governments, research institutes to expand limited supplies and reduce the fuel's cost. The fourth pillar is around advanced technology. And the next generation of aircraft will certainly be incorporating the latest digital design and production tools, airframe technologies, propulsion and systems technologies, and different power and energy solutions will apply to different market segments and aircraft sizes. We have several projects in place. We're studying a transonic truss brace wing configuration that leverages technologies such as hybrid laminar flow and very high aspect ratio thin wings for next generation efficiency. We also have a partnership with our Whisk joint venture, which is an all-electric eVTOL vehicle, and we've flown more than 1,500 successful flights on a 2-passenger configuration. We've innovated with hydrogen, green hydrogen, and fuel cell applications for over 15 years, which it's created great insights for us through these kinds of live demonstrations. So we see these 4 pillars underpinning the future of decarbonization of aviation, with SAF, sustainable aviation fuels, at the forefront, having the biggest impact to ensure aerospace is safe and sustainable. Thank you.
Thank you very much indeed, Naveed. As we're speaking, let me just kind of update you because I think it's germane to the conversation. The press conference continues in Brussels. Just for everybody's information, the EU is going to require a minimum 28% synthetic aviation fuel by 2050. It's planning to phase in synthetic fuels as part of the SAF requirements. So there's going to be a kind of move, quite an aggressive move in terms of the blends that we're going to be talking about. Chris, that kind of takes us towards you. Let's talk about what is happening on the propulsion front. A focus thus far on SAFs and sustainable aviation fuel. I'd be curious to know kind of what comes beyond that as well. But what's your take at the moment?
Sure, Guy, thank you very much. I'm very pleased to join my colleagues here today. Thank you for having me. Clearly, we find ourselves at a pivotal moment in the history of aviation. Sustainability is now the challenge of our time, and at GE, our ambition is to rise to that challenge. Advances in engine architectures, aerodynamics, and materials developed by GE and our partners have resulted in aircraft engines consuming 40% less fuel today and emitting 40% less CO2 than the engines manufactured in the 1970s and 80s. However, we cannot be satisfied with the pace of progress from the past. We're going to have to build a new chapter here. We are organizing our efforts in sustainability around 3 pillars. First is accelerating bold technology developments in our future engines to reduce emissions. Second, driving efficiencies in our own facilities to lead by example. And third, engaging across the aviation industry to advocate for advances like lower carbon fuels that will enable the installed base to operate more sustainably, critical to commercial aviation's carbon commitments, as Guy just outlined. Aviation is a long cycle industry, and while technology advancements can take decades to mature, GE Aviation is not waiting. We're continuing to invest in R&D to the tune of $1.8 billion a year, despite the industry's current challenges, so we can deliver jet engines that meet our customers' demands for reducing the environmental impact of flying. As one example, in June, we came together with our partner in Safran to announce the CFM RISE program, our technology demonstration roadmap to deliver at least another 20% improvement in fuel efficiency and reduce CO2 emissions for the next generation engine for future single-aisle aircraft. We plan to demonstrate and mature hybrid electric, open fan, and advanced materials technologies that could be incorporated in new engines as soon as the mid-2030s. Equally important is the work we've done to advance the use of sustainable aviation fuels, as we've heard from my colleagues here today, which offer 80% less life cycle carbon emissions than traditional jet fuel. Our first tests with biofuels were in 2007. We successfully operated G90 engines on 100% SAF in 2018, and all of our engines are capable of using approved SAF blends without modification. G Aviation is leading industry efforts with ASTM to define standards for 100% SAF, and we are advocating for constructive government engagement to help make SAF more widely available and affordable. Finally, we're empowering our 40,000 employees and embracing sustainability as a core value across our global facilities. We're using lean practices to identify and eliminate environmental waste, thereby reducing cost and our carbon footprint, consistent with GE's commitment to achieve carbon neutrality in our operations by 2030. So the future of flight will be defined by how we innovate to lower emissions and improve fuel efficiency, a trend accelerated by COVID-19's impact on the aviation industry. GE Aviation is rising this challenge with disruptive technologies to build a world that works, including open fan architectures and hybrid electric propulsion. We can't achieve this alone. It requires a collective, holistic global approach that GE Aviation fully supports, along with my colleagues here today. So that would be my summary, Guy.
Excellent. Good summary. Thank you very much indeed. Let's carry on talking about the propulsion side of things. Paul, let me turn to you at Rolls-Royce.
Thanks very much, Guy. And I share the others' honour at being here on a stage with fellow CTOs and to FIA Connect for organising this. So you'll hear many common themes through all of us, which isn't really surprising, that all of us believe that it's a relentless improvement to engine and airframe efficiency, the ramp up of sustainable aviation fuels, and the exploration of the novel technologies that together will reach decarbonisation, ideally net zero by 2050. I'm going to focus a bit on SAFs, the sustainable aviation fuels, which we know are going to be needed for medium to long range journeys, especially by 2050. And I'm going to sidestep what we mean by medium, because studies are still being conducted looking at the emission characteristics, viability and maturity of novel technologies, perhaps for those shorter range journeys. Compatibility of sustainable aviation fuels is pretty much being solved, as Sabina said earlier on, and we're on the way to certifying fuels into regular use if the fuels are available. But the issue is scale. And if we set ourselves the ambition of achieving 100% use of sustainable aviation fuels by 2050, which I think is an achievable goal, we need 500 million tons of that fuel in 2050. We shouldn't be scared of that scale. For interest, the world makes 80 million tons of bioethanol, which is blended into automotive gasoline around the world, and 50 million tons of bioethanol, if on an alcohol to synthetic fuel process, would achieve 50 million tons of sustainable fuel. So one might say, as the automotive industry moves to electrification, that bioethanol might be available to our industry. To achieve this scale, we clearly need partnership, because the companies represented on this call are not going to be the ones that produce the 500 million tons. It's going to be the big energy companies. And for that reason, last week we announced a partnership with Shell, Europe's largest company by turnover, who have firmly gotten behind sustainable aviation fuels. And our partnership with them will explore not just the technical pathways, but the other barriers to clear sustainable aviation fuels at scale. We need a global regulatory framework to make sure they're introduced, which probably means blend mandates or subsidies at source or whatever. But the regulators need to work hand in glove with our industry and with the oil and gas industry to create the right economic conditions for the investment to go into SAF scale up. And in terms of the technical pathways, we will definitely see generational changes from the sort of bio pathways that are used today and waste pathways into what's called e-fuels, which are fuels that are made by the direct capture of carbon dioxide from the atmosphere and the electrolysis of water using clean energy to synthesize a fuel using a well-known process. There's huge scope for innovation here, and I think it's almost dangerous taking a 2021 outlook on the ramp up of sustainable fuels, because I'm convinced within the next 10 years, this massive industry, and don't forget, in aviation, we use pretty much the same chemical formula as required for agricultural diesel or home heating. So the amount of innovation that's going into this area is massive. And we in aviation will be leaders, but also benefit from other industries using them. I mentioned efficient engines and airplanes, as did Chris and Sabina, and those will be needed because we know these fuels are not going to be as cheap as fossils. And so making ever more efficient engines and airframes is a key part of enabling the growth of those fuels as it closes the affordability gap. Thank you, Guy.
Thank you very much indeed. I'm going to come back to some of those points a little bit later. Eric, let me pick up with you.
No surprise, you will probably see that there is a very strong alignment across our professions. Be you an aircraft maker, an equipment maker, a propulsion guy, and so on. There is a strong consistency in the appreciation of what we have to do. So on Safran's side, as you know, we are specialists not only of propulsion, but also all type of aircraft equipment to be delivered to the system makers like Sabine, like Navid, and so on. So as far as decarbonization and contribution of Safran to decarbonization is concerned, our approach is, I would say, a two main pillar approach. How to decarbonize the products we are making, how to decarbonize the operations, industrial operations. For the products themselves, we have a threefold approach. First one is clearly directly linked with what has already been discussed just before, how to make an aircraft ultra efficient. And as far as Safran is concerned, what is the kind of contribution Safran can bring to this ultra efficient ultimate aircraft? So for equipments on board the aircraft, the first and foremost is for sure the propulsion system. And this is extremely consistent with what has been said by Chris, by Paul before. We are all striving at finding the recipes for the ultra-efficient propulsion system. So first of all, at the very beginning, it was referred to the fact that just implementing the benefits of the previous generation of engines that were developed in the last 10 days across the whole existing installed fleet will mechanically bring a 1 to 2% benefit per year during the coming 15 years. So this definitely is the first contributor to it. But now what we are looking at is the next generation. And what's the effort to be made for the next generation? So ultra-efficient engine, Chris, you referred to that. This, especially in the partnership between Safran and GE, this was announced last month, is a RISE program with very innovative technologies and system architecture that will, by the way, for sure require a system effort of integration of these new power plants on board the new aircraft. For Boeing, for Airbus, this has to be jointly worked out between the system makers and the equipment makers. The second aspect of it is the more electric aircraft and more electric propulsion system on board an aircraft. And for us also, we are making other equipment like landing gear, electrical equipment, APUs, and so on. Every time you can save some kilos, you're facilitating the design of the aircraft, you're reducing the weight of the aircraft, and the benefit is also on the consumption of the aircraft, thus the emissions of the aircraft. So this should not be alleviated as well. The second pillar for us is directly linked to what we said about the sustainable aviation fuel. So we are conducting the same effort, and we are all striving at having more than this 50% usage on board an aircraft. That is the current standard. It's already certified by all our solutions. Paul said, Chris, you said it, I'm saying it also. All our products are already able to fly with a 50% blend. The challenge is to make it as possible certified for the 100%. And the second challenge for sure is the scalability of the industrial vertical of production of this SAF, whilst finding the ways and means to avoid that this dedicated usage of SAF for decarbonization and aviation is not competing with other ways and means to produce biomass and things like this that would compete with other social priorities. So that's really a matter of scalability. That's a matter of incentives. We, as technology provider around the table, have the responsibility to make it happen from a technical standpoint of view, that it is feasible to use them. And then we have to create also the momentum throughout the society, I would say, to make this industrial happen in terms of ability to produce it at acceptable economic conditions. And the last of these pillars for the product decarbonization has to do with the so-called hybrid electric technologies. Hybrid electric with two targets, I would say, in terms of market ends. First, because going hybrid electric for commercial aviation is a way to implement this kind of technology inside the gas turbine and design it in a more optimized way, helping the gas turbine to go through some flight phases, for instance. So redesigning another way makes it possible to redesign it in a more optimized manner, maybe smaller size because helped with electrical assistance during some phases. And this is also beneficial for the fuel burn and for the mass. And the other way also to see a market target for this hybrid electric propulsion is also for smaller vehicles like helicopters or smaller platforms, if they can really fly hybrid electric, if not full electric, as some of you referred to. And as far as our operation need to be decarbonized, for us, it's the same kind of efforts we're making all throughout our facilities. But I would like to mention also something that is quite peculiar to Chris, Paul, and my activities, as a big bulk of what we are doing has to do with propulsion system. And when you look at the carbon footprint of our industrial operations, for sure, that is heating the buildings and so on, that the waste management, but a big chunk of this carbon footprint is directly linked to the tests of our engines before we deliver them to the customer. So working on ultra efficient engine is also reducing the fuel burn when we test them before delivering them. And this is also a key contributor to the decarbonization of our operations. So as Sabine, you said, I think we have the right targets. Some of the levers are in our hands as technology providers. Others aren't. They are depending, as some of you said, on the capability for the industrialists to produce the SAF in a scalable manner, in an economic manner. And we will probably need also the momentum from the politics to create the incentive to do it so. Thank you.
Thank you very much indeed, Eric. Yeah, we'll come back to the chemistry maybe a little bit later on, and we'll certainly be talking about the politics as well. Let's wrap things up. Mark, I give you the kind of final word on all of this.
Well, thank you, Guy, for hosting us. And I want to thank my colleagues for having this important discussion. I think you said it first, as we think about third era of aviation, the vision Raytheon Technologies has for a sustainable aviation future includes 4 elements: advancements in jet engine efficiency, extensive use of sustainable aviation fuels, wide adoption of hybrid electric propulsion, and optimizing the aircraft flight trajectories. We'll get there by first developing jet engines that operate much more efficiently and with reduced emissions, even greater propulsive efficiency from our geared turbofan architecture, around 16%, smaller and more efficient engine cores, and improved engine thermal efficiencies from higher combustion and turbine temperatures that are enabled by advanced materials. Second, we'll get there by bringing together the aerospace and energy industries to support alternative fuel solutions, such as sustainable aviation fuels and longer-term hydrogen fuels. The good news is that our Pratt & Whitney gas turbine engines are already fuel agnostic. We know how to design them to burn just about anything. Pratt & Whitney is exploring and expanding the use of biofuel for its operations in the United States, reducing our dependence on fossil fuels and emissions. And our engines are qualified to burn SAFs and are already flying with biofuel blends. Third, we'll see the development of hybrid electric propulsion systems to enable more sustainable aviation by pairing gas turbines with electric motors in a smart way to optimize the power plant efficiency through the flight envelope we see, just as today on roads with hybrid vehicles. This has been the potential to reduce fuel burn, CO2 emissions, and across aircraft segments. We are not just talking about replacing fuel with electricity. This is about optimizing the engine. Our Collins Aerospace business, along with Pratt & Whitney, are integrating pneumatic, hydraulic, and electrical systems to synthesize these complicated structures, thus bringing us together with aircraft OEMs in a world where electrification is prevalent. The fourth way is by optimizing aircraft flight trajectories to follow near optimal routes, altitudes, and speeds during all phases of flight, thus reducing delays, fuel consumption, and emissions. This will require several things to come together: more intelligence in the aircraft avionics, new automation and air traffic management, advanced air-to-ground data links, communications, and more accurate, timely weather information. By doing these four things, we'll be well on our way to achieving a sustainable future for aviation throughout the next 3 decades. This will take a lot of work from the aviation sector and my CTO colleagues. I represent hundreds of thousands of engineers, scientists, and researchers who are excited to solve these hard problems. It will require engagement by governments around the world and other industrial sectors, especially the energy sector that will produce the aviation fuels of the future. Raytheon Technologies is committed to our part in this equation because we believe we have a responsibility to change the world for the better. And I want to thank you, Guy, and my colleagues for having this discussion. I think it's remarkable how much we are on the same page. Thank you.
Thank you very much indeed, Mark. Yeah, I think you are all broadly on the same page. Certainly a big focus on sustainable aviation, sustainable aviation fuels. Obviously, the chemistry is going to be critical here. Feedstocks, trying to make sure actually the policy mix is going to work as well to encourage all of this. And certainly that is what we are starting to hear from the EU. So I'm going to have a little bit of fun here. I'm a news guy, so I'm going to react a little bit to the news. We're getting the news out of Brussels, so I'm going to get your take on it. A bit of a sort of quick fire round, not a yes and no answer, but let's try and get your take on what is happening here in terms of the targets. So basically, this is what the EU is saying. It's what Frans Timmermans has just announced in Brussels. The EU is going to require a 28% synthetic fuel, aviation fuel in the blend by 2050. That's going to phase in to the SAF requirements. The EU is going to require 2% of jet fuel in 2025 to be SAF, rising to 63% in 2050. Is that an achievable target? Is that a challenging target? Is that a manageable target? So let's go around quickly and just get a take on all of this. Sabine, does that sound like something you think this industry on its current trajectory can achieve?
I think it's really coming with, I mean, if we want to achieve that, these are things we need to radically go in the pace. Actually, I think everything is there, but we need to industrialize things. So the ambition is set. The role of SAF is recognized by us all, but the market is still not fully established here, and so we really need a reaction here in terms of incentivizing, not only regulating but incentivizing it, and then really industrially going for it. I think on the technology and the technical side, we've seen we can go up to 50%. We are also looking at how in the aircraft, what do we need to adapt to really make sure that 100% on a day-to-day basis would be no harm, and that we can certify that. In a lot of areas, we think it's maybe even positive for the systems. So we need to look at the fuel pumps, we need to look at the fuel system in order to be safe here. But I really do think that we now need to act at the overall ecosystem in order to industrially bring it forward. Because for the time being, so you said 2% by 2025. I think today we are at something like 0.01, if I'm not mistaken.
Yeah, it's a lot lower.
So it's really something on which we have to act. And I think in order to do our to show our ambition and our commitment into that, we've just launched as well internally how we would go forward and to really go, if possible, up to the 50% in our own flights. You know, that we have internal flights, that we have test flights, that we have as well logistics flights. So we are actually just now starting to look at what does it need in order to make it happen for our internal things, and then as well going forward with the ecosystem, because we do think that we have for sure our role to play as well as a big OEM here in taking the ecosystem forward and showing that it's possible. So that's actually one of the bricks that we have added to our, let's say, technology projects in terms of hydrogen, in terms of other possibilities, in order to bring as well the sustainable aviation fuel page forward and to show results quickly and to show that it's possible.
Okay, Naveed, do you think those targets are achievable, challenging,
Yeah, Guy,
straightforward?
I think yes, and I think there's some pieces to this that have been talked about. I'll just add to them if I may. Certainly the technical barriers, first and foremost, on the road to 100% SAF, you know, beyond the 50-50 that's currently possible. And as Sabina mentioned, you know, there's modifications to the fuel systems, the aircraft, the engine, to ensure that this new fuel composition is just as safe as today's conventional jet fuels. And then beyond the technical barriers, the key to the objectives that you just outlined, Guy, is accelerating scale. And that's going to involve a number of different elements, certainly things like incentive programs to make SAF economically competitive with Jet A for airlines and economically attractive relative to transport fuels for fuel producers. Access to capital to enable development of these new production capacity by the incumbents and also the startup fuel producers. Stable and predictable government policies to reduce the risk and enable government support mechanisms to de-risk this capital. And then I think the policies that you just have mentioned, plus broader ambitions of our industry, is going to create a strong demand signals from airlines, travel buyers, environmental organizations for SAF that meets the required sustainability criteria.
Excellent. Paul, what is your kind of thoughts on this? How do you see the engineering challenge? Is it up to the task?
The problem isn't the engineering. The problem is the economics and the scale. And we would fully support this approach, that having a blend mandate drives the market. So effectively, aircraft now can only fly with a varying blend of sustainable aviation fuels. That provides the certainty of market for the oil and gas companies, who then can invest in the scale up to provide them, and then we decarbonize aviation. So in my mind, it's a sort of a perfect circle. And can it be done? Yes, of course it can be done. Just have a look at the kind of vaccination crisis around the world, and just how much the world has reindustrialized to produce billions of doses of vaccine. It's that sort of spirit that's going to be required to get the scale into sustainable aviation fuels, and I think it's entirely possible.
Eric, you are still muted, by the way.
Yeah, probably my mouse pad. Yeah, okay. Fully in line with the feasibility of the engineering challenge, especially for this horizon. We will have to clearly investigate the safety aspect of it. That's just obvious. Safety and also durability. I mean, life cycle duration of the product, digesting these new fuels. So this is these are the specific engineering assessment plan to make it a viable solution in the long run. So as far as engineering challenge is concerned, I'm not worried about this. I fully concur with the remarks made about how to turn the economic challenge into reality. And maybe an additional comment, in our various roadmaps, both aircraft makers and equipment and system makers, you have seen that we incorporate the SAF route and also hydrogen route. And probably it's wise to do so, to investigate as fast as we can what has to be done to accelerate the route of the SAF, because this is within reach in a short to mid term, but also to secure the perspective in a more long term of hydrogen as a promising media to take over or complement the SAF route as well. And we are not at the same level of maturity today. What is at a technology readiness level of 5, 6 and more and ready to be applied on the SAF route is more level 3, 4 in the hydrogen. So that's the reason why probably among all of us, you will find the SAF pillar and the hydrogen pillar with different targets in the short term, check the feasibility of hydrogen options to find the right route with the hydrogen, whereas on the SAF, it's just accelerating the actual implementation of this solution because it's a much shorter term feasible option.
Yeah, it's interesting, the twin track kind of policy you're talking about there in terms of the different timelines and them being slightly out of sync, but nevertheless, maybe the hydrogen ultimately being the long-term destination. Chris, what do you make of the targets? Achievable, not achievable? We've talked a lot about engines being compatible to fly with SAFs up to 50%, but we've also heard a lot about kind of safety already. We've also heard about longevity of components being an issue as well. What do you make of these targets?
I mean, it's certainly an aggressive goal. I think we can all agree on that, but we need aggressive goals. I think what's encouraging and what I would maybe add to what my colleagues have said is there's been so much discussion about 2050 in the industry, but so little discussion about what happens in between. And so I'm hopeful that this announcement will be a catalyst to say we need to have a real call to action sooner to get the SAF industry built up. My hope is that this will get to more harmonize the restrictions and requirements that will be around the world and not just in the EU, and that it will provide some support and incentives to really get this industry moving in the way that we want to. Certainly the trajectory we're on today, as we mentioned, at the level of SAF that's being utilized today is not where we need to be. I would hope that this announcement would put us on a better path, and I look forward to hearing more from the EU about how they intend to help support the entire ecosystem to make this a reality.
Yep, the devil is always going to be in the detail. Mark, let's wrap things up with you again. I think that's an interesting point. These are aggressive targets. We need the detail. We need to figure out exactly how the scaling is going to work, particularly on the SAF. It does come down to the chemical engineering in certain instances, feedstock availability, balancing out with diesel. There's lots of challenges here. But what do you make of the sort of the overarching targets that are being laid down?
So Guy, I think it's important to understand that it's all multidisciplined. The engineers like to solve hard problems, but it includes electrical engineers, system engineers, all the components. Right now, our engines can run on 100% blend of SAFs, so I don't think that's going to be the issue. I think in the short term, SAFs will work, and there'll be some technology work. And in the long term, hydrogen will have different problems. There's bigger volumes and so on. So there's some significant, as I think my friend Eric said, in between those time periods, there'll be some work to be done. But a word, as Sabina said, was very important: ecosystem. So I like that word because it's a partnership amongst many factions, and in many cases, policy and government has to move along to help us all pull together. Paul said something very important, that the energy companies will not make big bets without some assurity that those bets make sense because they're significant. And I also think that the way we should think about the whole issue is that it's a partnership. Sabine, Navid, Airbus, Boeing, so on, are going to have their arm around the engine suppliers. We're certainly going to do this together. And I guess since I'm sitting in the United States today, Guy, I'd like to mention that we're working with a partner in the Department of Energy. We have multiple contracts that push hybrid electric, to think about the systems, the ATC, air traffic control routes. So I think, it's all governments, beyond the EU also, we're all playing in a very similar way. And I think it's important to partner with them so they get buy-in to what the future policy should be. So Raytheon Technology is looking forward to this journey. And I like the idea of what do we do along the way.
Okay. Really interesting answers, and it sets us up very nicely as well. Lufthansa, just at the moment, calling for a level playing field with non-EU carriers. They're already clearly concerned that this will create some imbalances in the aviation world. So the EU's proposals would damage competitiveness. So the customers are already starting to voice their concerns about some of these targets. I want to come back, Eric. You talked about the twin track kind of approach here, that we need to, that they're out of sync. SAF sort of comes first and is more easily, I say easily, is scalable right now. We understand the kind of trajectory that the hydrogen comes after that. Eric, what do you think the timeline is? How long are we going to be in the SAF phase? When do you think hydrogen will start to become competitive in terms of other options? It looks like it's going to be a more kind of long haul solution, but I'm curious, as you see these two timelines unfolding, ultimately, when do we get to the tipping point between SAF and hydrogen?
Yeah. So for the sake of clarity, first, let us all keep in mind that for sure, hydrogen usage can be seen two ways, either as a fuel to be burnt in engines or as the fuel for generating electricity through fuel cells. And this is not the same end market, even if aerospace industry can be interested in both. For the hydrogen as a fuel to be burned, it's clearly what you said, Guy. When will be the tipping point to substitute eventually SAF with hydrogen or complement? Whereas for hydrogen as the fuel for fuel cells, it's all about how to scale up the technologies of the fuel cells that are a few tens or hundreds of kilowatts maximum today, up to the megawatt scale or multi-megawatt, to envisage that a full electric multi-megawatt engine could be a substitute to a gas turbine, for instance. Okay, so that's the reason why, for the sake of clarity, when we talk about hydrogen, very often we have inside hydrogen two ways. If I stick back to your question, that it was more pertaining, I think, to the fact that hydrogen could be a substitute to SAF, to be burned into engines. If we look at where we stand today in these technologies, it's the subject of hydrogen for aerospace to be burned in engine is clearly a subject to be deeply shared between the system maker, the aircraft maker, and the propulsion maker. Why? Because you may have an engine that is fully agnostic, as Mark, you said, burning fossil fuels, SAF, or hydrogen, because the technology of feeding this engine with these three type of molecules and burning them in a combustion chamber is mastered. But it's not the same thing having fossil fuels or SAF on board an aircraft, or having an aircraft capable of storing and delivering and conditioning the hydrogen in the appropriate condition to be burnt in an engine. So that's why I should try to answer first, what kind of technology hiccups or barrier or hurdles have to be alleviated at engine level to make it simple, and when, and this is typically quite short term. This can be addressed in a, let's say, 10-year maximum time scale, to check, well, this engine, I can turn it so that it burns now hydrogen. But on what is the time scale for creating the condition on board an aircraft to have an aircraft capable of doing this? And this is not my business, so for sure I will leave the floor.
Well, let's pick up on that point then, and turn to Naveed. Naveed, when are we going to be capable of having the airframes that are capable of providing the opportunity to put hydrogen on an aircraft? Obviously, we're going to be looking at different designs. There is the volume issue. It's going to be compressed, but there's going to be obviously a volume issue. There is a redesign of the airframe, and obviously we're going to be dealing with a lot of composites here. I'm just wondering what you think the timeline looks like to get an airframe ready for that kind of purpose?
Yeah, Guy, thank you. And as you mentioned, you're exactly right. There's volume constraints, there's the temperature of that fuel, and that'll drive configuration changes. If I may, just to step back, we see not just two paths, one of SAF and one of hydrogen, but we see others as well. We are investing in electric hybrid propulsion systems, as well as all electric. And both of those kinds of technologies depend on the mission you're serving. They certainly look different than long haul transcontinental travel, where battery density will not solve the problem. We're doing our homework on hydrogen. We have, in fact, flown 5 demonstrators using hydrogen technologies in our history. But it certainly remains to be seen where that's going to go in the safe operation in commercial aviation. Okay.
Yep. I think there are a lot of unknowns here. Sabine, what's your take on this? When do you think airframes are going to be ready? We still haven't nailed down. We still don't know exactly what the beyond SAF, what the propulsion systems are going to look like. And clearly there will be, as we've just heard, different routes requiring different outcomes, short haul, long haul, and the time to hand over will obviously be different as well, from SAF into other opportunities. I've seen turboprops that you guys have put out there. I've seen blended wings. The engineering challenge of sort of scaling that, though, I think is very different. How we talk about sort of scaling, say, the sustainable aviation fuel. How easy is it going to be to scale the new airframes, the engineering challenges around them, and how compatible is that with the timeline on the propulsion side when it comes to the switch from SAF to hydrogen?
Yeah, thank you, Guy, really for putting this up, because everybody, I think, our ambition, and we are fully excited on the overall step change into zero emission, towards zero emission, and as well the technology step change that we will have to prepare. And for sure, I fully agree with my colleagues here that we need to do not only one way, but we need to investigate in several ones, and SAF stays one, and because for the long haul flights, short and midterm, there is no alternative today. And I think if I'm looking, there is, yes, 72% short and medium haul flights, but they are doing 25% of the emissions. So there is a big part of the emissions coming from the long haul, and we will have to attack it with SAF. So our ambition is clearly to have a flying aircraft on the market in 2035. So that's a clear target and a clear date. So today we are, exactly as Eric explained, we are looking into the different possibilities, hydrogen combustion, but as well fuel cell, then hybrid electric possibilities. And we are really, in order to make it scalable, we will need to understand the basics still. What does it mean for an aviation application really, and what do we need to prepare? And this is what's ongoing now. So we will take our decisions in the technologies and in the segment that we can put it out first in around 24, 25. And in order to be ready to then have a real industrial system ready in 2035.
Thank you, Sabine. Paul, quick question to you. I can't remember if it was the FAA or one of the other regulators, but I certainly saw a comment a couple of days back voicing concern about hydrogen and safety. We're going into a whole new propulsion system. Regulators are going to want to be very, very careful in terms of the way that they approach this. I'm sure they're going to be very careful in the way they approach SAFs as well, but that feels like a more understandable and current technology. Paul, in terms of understand, how big a challenge is it going to be to convince regulators that what you produce is going to be something that we can roll out at scale around the world?
You mean in hydrogen, guys? Is that what you mean?
Yeah, in hydrogen.
Yeah. So I guess the first thing I'd like to do is answer a slightly different question, then come back to your question. So you can behave like a broadcaster, I'll behave like a politician. We shouldn't necessarily think of hydrogen as being a sort of an ultimate replacement for SAFs, and SAFs are an interim measure, as Sabina said. Look, the world has signed up to net zero by 2050. Well, most of the world has signed up to it. Certainly that was the Paris Agreement. And net zero means that the anthropological emissions, man-made emissions of greenhouse gases are balanced by what we absorb. And SAFs that use no carbon in their manufacturing pathway, as they won't by 2050, are a net zero fuel. Now, there might be other reasons why you might want to take other pathways, and it might be that hydrogen is cheaper or something like that, but it's not climate change. The climatologists say that it's net carbon dioxide that is causing temperature rise that we have to limit to 1.5 degrees by 2050. So we shouldn't use the language of SAFs now and hydrogen in the future. They're parallel pathways, as I think many of the speakers have said. Then coming back to your real question, in aviation, we stand on the shoulders of 60, 70 years of aviation safety. And safety is our number one priority. We don't do anything in aviation without enormous scrutiny of all of the safety consequences. And many of the companies on this call will know that sometimes, what can seem small technological evolutions actually involve quite a lot of engineering challenge when it comes to meeting aviation safety barriers. So once we've proved the viability of hydrogen and the configuration of it, the next challenge is engineering maturity. And I would say, that is an area where we're about to start exploring what it takes. And we underestimate that at our peril. We've got to look at the whole system solution, how the hydrogen's made, how we burn it. And many of the people on this call have said, Mark and Eric have said, and Chris have said, it's not hard to burn it in a gas turbine, for example. But then how do you manage it at airframe level? How do you produce it? How do you tank it in a way that the regulators will be happy and say, yes, it's achieved the same safety levels as we've achieved in aviation today? And that's the question. And I think it's a question that the industry is still asking itself.
Okay, we'll maybe come back to that one another day. As we say, we're kind of accelerating the process at the moment, but a lot of unknowns. Mark, let me kind of wrap. I've got a couple of minutes left. Let me wrap things up with you. When we look at all of this, are we, and we talked about this earlier about the whole ecosystem, are we thinking enough about ATC? Are we thinking about how airports are going to adapt in terms of the challenges there? Just kind of walk me through your thoughts on this. The European Union, and again, I keep coming back to it, it's been very slow in terms of adoption of a single sky, in terms of the new evolution, in terms of ATC. Are we kind of, we're focusing on propulsion, we're focusing on airframes, but there are other parts of this industry that need a big focus as well.
So Guy, thank you. And it's great to be part of this conversation. I'd like to orientate you strictly technically. You have CTOs here, so bear with me. When you do this in the future, and you'll have many of these conversations with CEOs, governments, you're gonna tease this out. Think about technology in a way where in the near term, the public thinks we're there. They overestimate where technology is. In the long term, we underestimate where we can get, because we have all these unknowns. So my view of life is today, everybody's assumed these technology problems, like Paul said, are kind of done and we're there, right? Somehow that all works out in the public's eyes and the people you talk to. In actuality, there's going to be knowledge points that you're eventually going to ask us about. So as Naveed said, say we go to hybrid electric. Well, maybe we need high voltage or megawatt, sources or something. But you're going to ask in the future about the few technology challenges we're all fighting. Because I think that's where you're going to give our people who watch you, people who want to know, this is a great challenge. This is when you start. We just saw a space travel. Guess what? There was an insatiable need for people to learn, well, what did that take? How did they do it? And I think right now we could all give you the next 3 or 4 big technology challenges, and a little bit more meat that the engineers are going to be solving over the next few years. When you hear that we have solved some basic problem, because we all built engines with hydrogen, we did it, 1950s. But how do we actually make it safe, prove that it's safe, have the engineering maturity we need?
I think we're slightly losing you, Mark, unfortunately, which is maybe an opportune moment to start to wrap things up. Mark, we're going to leave it there. You're slightly blurring, so we can't hear you anymore. But I don't know whether that's the engineers in the back office telling us all maybe that we should be wrapping this thing up. Thank you so much, all of you, for such an insightful and informative panel. It's been a great pleasure to join all of you, and thank you for joining us on this FIA Connect event.